Hello, everyone, and welcome to Biology 1. My name is Mark Eastburn. I am also co-teaching this class, first with Diane Canellis and then with Helena Koflewicz, who will be coming as a member of my teaching team around Thanksgiving time. The best way, easiest way to reach me is via email, or if you're so inclined, I've been encouraging students to do this as well. There's an app called Remind, which you can get on your phone. There's also remind.com, a website. This class code will allow you to connect, allow students to connect. That's going to be the fastest way to communicate with me if there's something urgent. Email I check regularly, but not as much as Remind, which I do happen to have on my phone, and that's really the easiest way to contact me. I send out messages about assignments there, reminders. I'm hoping to eventually transition over to Canvas, which is the online platform we're using. But at the moment, I know that Remind works. There are no hiccups in communicating. So that's the way students and parents can communicate with me. Now, being a science teacher, I've been inspired by the work of many scientists. It just so happens most of the most inspiring scientists to me have been astrophysicists, astronomers. The reason why is because anyone who can take the Earth and look at it as that tiny little dot, I think really puts things in perspective in terms of how we are as a society going to move beyond this tiny little dot and hopefully expand our knowledge and expand our horizons off of the Earth. Now, the two quotes that I like to share, and I've shared these with students also, is one from Carl Sagan, who you'll see as a continual inspiration of mine. We live in a society exquisitely dependent on science and technology, in which hardly anyone knows anything about science and technology. This is a clear prescription for disaster. As I've told students already, even what we're seeing right now with the fires in the West Coast, previously fires in Australia, previously fires in the Amazon during the dry season, the consensus in science is that climate change is happening. And then we see these indications that would confirm what people are saying. Same thing might be true with mask wearing, where we know wearing masks prevents the transmission of coronavirus. But there is a very strong streak of science denial and misunderstanding of science in society today. And I think Carl Sagan's words, even though they were spoken more than 30 years ago, are still very relevant. And this is kind of the challenge. I want to capacitate students to understand better how science works and what science tells us. And therefore, as an educator, it's my duty to empower students to think so they can go forth and think accurate thoughts about how this world is put together. This is especially relevant for biology as we are living organisms and as we're surrounded by living organisms. And that's extremely important understanding to have. In terms of the sciences, I certainly agree that biology is one that needs to be required. I might have different opinions about other forms of science, but I think biology is absolutely necessary for every child to pass through high school with an understanding. My background, I do have 2 degrees in biology. I got my biology bachelor's degree at St. Mary's College of Maryland, which is a small public honors college in Maryland. Big fan of Maryland and the state, so I was happy to spend 4 years there while I was studying. I also got my master's in biology from Villanova, which is a little bit closer to home. In between my bachelor's and my master's, in addition to teaching for several years, which I taught at Johnson Park and Riverside prior to coming to the high school, I also served in the Peace Corps, where I had a lot of engineering experiences. I also teach the engineering class, and I also had a lot of opportunities to use my background in biology to improve soil, to vegetable garden with rural farmers in a remote village in central Panama in the mountains. Iguana ranching, I taught them to raise iguanas as a food source and as a way of encouraging planting of trees. And when I came back from Panama and the Peace Corps, where it was for 2 years, I got my alternate route certification in Spanish elementary education. I was an elementary educator for 17 years, 10 years at Johnson Park and 7 years at Riverside. biological sciences and chemistry. Outside of that experience, I do write in my spare time. I have a book that came out in 2016 called Earning My Spots. It's about a boy who can shapeshift into a hyena and the adventures he has. I also raise insects, which these are the roly-polies. These are the isopods that I sell. In addition to that, I raise insects and mealworms to eat, because I'm going to challenge students to think about this over the course of our time together. We have a continually growing human population. We're at almost 8 billion now. We'll be at 10 billion by the time that students are our ages in our generation. We have 10 billion people. That's another 2 billion people we're adding to the earth. In order to feed that many people, we're going to have to be much smarter and more careful about how we raise our food, how we produce our food, what we eat. If the entire world wanted to eat hamburgers, we do not have enough land on this entire planet to raise the cows we would need in order to feed everyone hamburgers. Insects provide a lot of protein with minimal food inputs, which means we can grow a lot more food for a lot more people with just as high protein as a hamburger. We would just make it a bug burger instead. And I do eat mealworms and I do eat crickets. And I'm hoping to challenge students. I'm the teacher mentor for the entomophagy club, which is the insect eating club at Princeton High School as well. So if any of your children happen to be interested, they can contact me about that. I also like to take photos of nature. This is me when I was getting my master's degree studying plant-eating spiders in Central America. This is me in Panama. I was also in Mexico and Costa Rica doing this study. This is one of the species of spider I happened to discover living on an ant plant system, which was really the focus of my research. At Johnson Park School, I transferred some turtles and I released them in the courtyard. So those turtles are still there and doing well. And at Riverside, where I was for 7 years teaching science, I was lucky enough to work with Mr. Cirillo, who was amazing mentor to me, and he allowed me to get a frog pond at the courtyard. So I always think of frogs, and as you'll see in my class, I talk a lot about frogs because I think they are such a valuable and useful vehicle for teaching about biological sciences in so many different ways. I did do a survey the first day, and it turns out some students don't like frogs, which was quite a surprise for me. I usually go with the assumption that most people do like frogs, or at least it's easy to get students to like frogs. Couple of more things just in my own experience. In 2016, a student came into Riverside, a kindergartner, with a little lizard in a container. And I asked her where she got it, and she said that her mother found it in some salad greens. And the story got a little bit changed, but it was a viral story that actually went around the world. And even today, if you Google or go in another browser and put in lizard salad school, you'll find articles from all around the world about this little lizard green Fruit Loop, which I still have in my care, and I hope to bring into the classroom when we're back in-person sessions. In addition, that kind of started a journey when I was a teacher at Riverside. I was looking for opportunities for students to learn more about reptiles and amphibians. I went to a conference about reptiles and teaching about reptiles in North Carolina, where it just so happens the eastern box turtle is the state reptile. When I came back, I told students that the eastern box turtle is the state reptile of North Carolina, which prompted students to ask, what's the state reptile for New Jersey? And as it turned out, we did not have a state reptile in New Jersey. So starting in 2016, my students were able, and I was able to help them get a bill recognized in the General Assembly. We have Assemblyman Zwicker and Assemblyman Fryman, who were able to get a bill into the New Jersey General Assembly recognizing the bog turtle, a critically endangered species that lives in New Jersey and has a stronghold in New Jersey. Get that recognized as the state reptile of New Jersey. And then in the Senate, we had Senator Kip Bateman, who also sponsored a bill that would recognize the bog turtle as state reptile. And then in 2018, Governor Murphy came to Riverside School and signed the bill into law. There I am in the background. I'm happy to say this was the very first bill that Governor Murphy signed. So I don't know what people's politics are, but I'm happy to say that the governor did sign our bill into law, and now the official reptile of New Jersey is the bog turtle. And a lot of students who I previously taught at Riverside and students at Community Park were also involved in making that happen. The topics that we'll cover for this year, right now we're kind of into why is biology important and relevant to their lives. I'm trying to make this as accessible as possible. Also, the process of how science works. There's such an essential need to understand the scientific process. Real science versus pseudoscience. I'm going to teach students about the CRAP test, where we look at the currency of research, the relevance of what a certain claim that's being made has to a further understanding of science. The authority, who is writing articles, what background do they have, and then the purpose of why they might be writing an article. There's a lot of pseudoscience in the world today, and my hope is to give students the toolkit they would need in order to distinguish what is real science, what is scientifically verified, and what is pseudoscience, which unfortunately, I tell students this, that real science is oftentimes losing the battle to pseudoscience. Far too many people accept, studies from unreliable sources, studies that don't really inform what a conclusion might be or what a policy might be that a government might enact or a community might enact. We don't have those broad understanding of science and its relevance and its importance. And therefore, as a whole, society is suffering, in my opinion. We'll get into the origins of life, cell theory, biochemistry, nutrient cycles and nutrient cycling. I'll try to tie this to what happens in our local area, in our Princeton community, in terms of like eutrophication, nutrient runoff. We put more nutrients, we put more fertilizers on lawns than anything else in the United States, and so that is our biggest crop is grass. If you look at the pesticides and the fertilizers that are used in what we would call agriculture. Genetics, genetic engineering, there's a huge promise and potential that happens when we talk about genetic engineering. Anatomy and physiology, so how bodies of humans and other living things work. We'll talk about evolution, natural history, how we might classify different organisms, and then really what's closest to my heart is the ecology, the natural systems. How do natural systems function to sustain life on this planet? And not only that, but what could we possibly do to harness those natural systems to cure some of the problems that we're dealing with today? And talking about things like climate change or habitat loss or pests, invasive species, all sorts of things like that. And then I'll try to incorporate some cutting edge research along with the topics at hand. When I talk about my own teaching philosophy, one of the quotes that always sticks with me is another one from Carl Sagan, where every kid starts out as a natural born scientist. And I certainly saw this as a elementary school teacher for so many years. And then we beat it out of them. A few trickle through the system with their wonder and enthusiasm for science intact. My hope is that I'm not too late. One of the reasons I wanted to go to to the high school was once they come out of middle school, maybe they've been beaten down a little bit. I want to hopefully bring them back that enthusiasm for science and understand they can do science, they can understand science, and they can make better sense of their world with that scientific viewpoint. In terms of the education, one of the most impactful experiences I had was as a young teacher was going to an education conference where a teacher who had just returned from several years in Japan presented a scene like this as her critique of what happens in certain other countries in terms of the educational system, where students are rigidly held to expectations, and anything that might step out of that, any growth in a direction that might not be the teacher's expectation, is quickly clipped and quickly rounded and quickly stopped from getting out of what would be perceived as getting out of control. And unfortunately, this is where students are forced to conform to a certain expectation of society. Now, I'm not saying that that's definitely how the educational system is in Japan, never any other country. This is just what this teacher presented. And my goal is not to force students into some expectation of what a model student should be. I realize that all students may grow in different directions. However, the metaphor this teacher used to represent an American student was a tree growing in a field. And this tree is free to grow in any direction that it chooses. This tree is free to expand in any way that it wants to. However, another teacher at that conference pointed out a very important point when it comes to this tree. And you might notice, yes, this tree is big and tall and growing in all directions. This tree has also been given every opportunity to grow because every obstacle has been cleared from its way. Another thing that may not be realized here is that this tree is not connected in a community. This tree is not growing the way a tree should be, which would be more in an environment like this. So this tree is actually much weaker than a tree in a forest because this tree has very little resilience in terms of its growth. A big windstorm would blow this tree over. A drought would dry this tree up. These trees have much more strength as a community. And the reason for that is because what happens below the ground. And this is what I'm hoping that students can appreciate, and teachers and all community members, parents as well. What makes a tree strong in the forest is not only the ability to get sunlight, but connections between roots, connections in a community. And these connections extend between different types of plants, different types of trees, between big trees and small trees. And the tallest tree in the forest that might think that it's so tall and wonderful actually needs all of those other community members to thrive. If this tree has all of the other members of the community cleared away, this tree will suffer. This tree will not grow properly. This tree will be like that one in the field, which is actually very weak. The small tree needs to understand the small tree contributes a lot to the community. The small tree has just as much to offer as the large tree does. So I want students to understand that grades are not the only reflection of who they are. Athletics, whatever it happens to be, are not the only reflection. Everyone has something to contribute to the community. And it doesn't matter what kind of student they are, but that diversity is what makes a community strong. If I were to refer them or take anyone to a tree plantation where the natural forest has been cleared, and I saw places like this in Panama, this is not a healthy ecosystem. These trees are not very resilient. This is all one kind of tree in a artificial sort of a community. And if you go to a community like this, there aren't butterflies flying, there aren't birds singing. It's an eerily quiet place. And this is not a robust community. Diversity is the key. Diversity of learners, diversity of personalities is really what's going to be the most important in my class. And I'm hoping that students can build those connections. And that sometimes means, as we had a conversation in a recent class, just finding ways of connecting with students. Students were asking about Albert Einstein and relativity, and while that's not necessarily linked to biology per se, it's a way of understanding science. It also is a way of tying students to the Princeton community, since Albert Einstein once lived there. So that's what I'm hoping. Even if we go into tangents among conversations with students, we're building those links, we're building those connections, which will make all of us stronger and hopefully make everyone appreciate my subject and my discipline as a scientist more. So I wanted to welcome everyone on board, and if anyone has any questions, In case I missed anything, this is the way to contact me, either through email or through mine. Thank you very much, and I really look forward to working with your students, and I'm really hoping we can be in the classroom fairly soon. Thank you very much, and even if you aren't in the classroom, I will assure you that students will be covering all of the content if they choose to continue to have class online. So I'm hoping for a enriching and fulfilling experience for everyone. Thank you very much.